we'll switch to English for this presentation. And so for anybody that needs devices, maybe now's the time to get them. George, again, thank you very much, and thank you, distinguished guests, ladies and gentlemen. I'm really honored to be here this morning to address you, because the project that you have participated in is really important to the Group on Earth Observations. And so while the title of this is Agriculture and the Role of Earth Observations, I hope that by the end of the talk, you see that we've got a tremendous challenge globally, internationally, to start integrating information at many different levels. So whether it's globally and internationally, regionally and or nationally, obviously down to local information, that's really what we're about. So the first part of this presentation is just going to set the context a little bit for the organization, and then we'll weave into some real, what I call are important enabling structures or mechanisms, and then clearly end up with the specific ties to agriculture. So for us in the Group on Earth Observations, when we are talking about observations, Earth observations, I want to be clear, it is not just space-based observations, while those are very, very important. We're talking about any observations in, on, or around the Earth. And so it's important to bring all of that information to bear on the particular issues. So while we often are quite upstream, because we think, we know that we've got to realize a future wherein decisions and actions, and there are hundreds of thousands of decisions and actions that are made every day around the world, need to be made for the benefit of humankind. And what we'd like to ensure is that they are informed by coordinated, comprehensive, and sustained Earth observations and information. And if you think of each of those words, coordinated, comprehensive, and sustained, then you can derive a whole series of requirements from each one of those words. Coordinated within national governments, between and among institutions, around, then if you go up regionally, across governments and our countries, and then when you think about just the fact that they've got to be comprehensive, we have a lot of information that's being collected, whether it is from space-based sensors, airborne sensors, marine-based sensors, like you see on the left-hand side of this graph, but they're also around each of these domains. Now, for today, agriculture is very, very important. Yet, one of the speakers this morning already talked about the role of biodiversity and ecosystems. Clearly, the fact that climate is a tremendous driver. When you think of each of these domains, agriculture, biodiversity, climate, disasters, all the way down to weather and water, a lot of the information that we're collecting in, on, and around the Earth is collected in each of these individual domains by different people, by different institutions. And so the challenge is to bring all of this information together so you've got the right information at the right time to address the issue of your particular concern. So in our particular area, we've got four very, we would say simple, although difficult to implement, objectives. Improve and coordinate those observation systems globally, provide access to data and information, advance broad open data policies. I'm going to come back and pay a lot of attention to that a little bit later in this presentation, and then ultimately to build capacity. And again, I think what we heard from each of the speakers this morning is that there are elements of each of these objectives going all the way down to building capacity, which are so very important. When you look at our organization, this says 98 member states. We now have 100. Kenya and Somalia have just joined recently. We've got pretty good coverage over the globe, yet you will see we've got some challenges. South America, certainly some challenges in Africa. We still have challenges in the Gulf state regions. And while we are not a United Nations organization, 98 or 100 member countries is still only half of the member countries of the United Nations. It's about 100, I think there are 194 countries now in the world. And so there are a tremendous number of Pacific Island states that are not yet members of GEO, and yet when you think about the challenges of climate change, those are going to be some of the countries that are most susceptible. I think what's important for us also, and particularly for you in the room, is that we have another category of membership called participating organizations. And a little bit later on, you'll hear from Isa. I've circled Isa on this graph. But for this audience, IBEC and the role that the Inter-Balkan Environment Center is playing is essential. Because while we're trying to integrate these Earth observations internationally, somehow we've got to downscale this work either regionally and or nationally, because that is where many of the decisions are made on a daily basis. So again, just appreciation to George and the entire IBEC community for joining GEO. It is essential that these coordinating mechanisms come to the table. But it's not just governments, it's not just participating organizations, and again, the speakers this morning already alluded to the fact that the private sector needs to be engaged in this effort. Now, the private sector or the commercial sector is really quite broad. There are data providers. Some of you are in the room. There are certainly value-added providers, those small and medium-sized companies that do something with the data that's collected in this upper tier. And then there are your verticals or your downstream sectors, in this case for agriculture, for our interests, agriculture, energy, water, each of those downstream verticals. So it is a broad and diverse group of private sector entities that we are still interested in engaging with to ensure that Earth observations are feeding those decisions. So let me just tell you real quickly on how our entire infrastructure is set up, because there is a lot of information that would facilitate and help the work that you're doing. Clearly, you've got those societal benefit areas or those verticals up at the top. There are many observation systems down at the bottom, but what you really want to do is bridge those observations that you see on the bottom of this graph with the use cases on the top of the graph. So we've got a discovery and access infrastructure or a brokering agreement, and I'll come back to that in a minute because it's a very thin infrastructure. All of the information stays resident with those agencies and institutions that are collecting that data. So while we have this discovery and access broker, it's called our GeoDAB, in the middle of this graph, we have a home page, we have a portal that's operated by the European Space Agency. This discovery and access broker is operated out of Italy and the CNR, their research institute, but it has access to all the information that you happen to see on the left-hand side of the graph. So as soon as these institutions on the left-hand side make their data available, what we are interested in doing is discovering it and accessing it. Those home institutions control the data. They still control the data. So for us, it's a discovery and access mechanism. And then, of course, a nod to the private sector that we are entering into interoperability agreements with them. While we recognize the private sector may work on different data policies, if their catalogs of information are made available, then people coming into the infrastructure can at least determine where there is higher resolution data. You may have to pay for that data, but you could get access also through this infrastructure. So let's dissect that a little bit. There are tons of providers tens of thousands of data providers around the world, and they're shown in each of these systems. So just imagine the agricultural systems in each and every one of your institutions or countries who are collecting some kind of agricultural information. There is this middle discovery and access broker component. You want to be able to discover and access that information, but why? It's not enough just to be able to discover and access it. You want to make sure that those application developers, whether they are in federal institutions, in government agencies, in universities, and or in the private sector, can start coming in and adding value to this information, because that is the mechanism that will ultimately provide the feedback loop to those data providers to make sure that you're collecting all the information that you ultimately need for your particular application. So it's a gigantic ecosystem that I think, cannot be governed from any one location, but with policies and practices so that this information is more open and available, we can in fact create a world where Earth observations will inform these policy decisions. I will say that for the first 10 years of GEO, we were going out and trying to get every institution to register their data to our metadata standards, and it was a failure, because each of your institutions, you have metadata standards, you have QA/QC procedures which you put in place. As soon as we put this discovery and access broker in place, so the machines could talk to each other, the access to data went up immensely. So back in 2010, there were maybe 300 Earth observation resources that were discoverable and accessible. That number is now up over 200 million assets across the entire globe that could help your investigations in agriculture. So a tremendous amount of work. This next slide, in some parts of the world, is a little controversial, but I want to put it up here because I want to make it clear that whether you are Uber and you've seen the advertisements about the largest rental car company in the world, yet Uber does not own one rental car. You know about Airbnb, the largest hotel industry in the world, yet Airbnb, do not own one hotel room. In a way, GEO is that way. We are one of the largest Earth observation brokering agreements, but we do not own one piece of data. You own the data. It is your information. So all we're interested in doing is brokering access for citizens of the world to your information. So we very strongly believe for government collected data in full and open exchange of that data, that the data and products be distributed with minimum time delay and at minimum cost, preferably free of charge or the cost of reproduction. Now, there are some good examples around the world where this is happening. There are many more examples where it's not happening. And I guess what I would like to show you in the next couple slides is that if your governments are interested in building your economy, then broad open data policies are good for your economy. Clearly, they are good for more transparency of environmental issues that are occurring globally, but it also makes business sense to share your data more broadly. So some examples, personal experiences. I worked most of my career with the U.S. Geological Survey, a government agency in the United States. We had operational responsibility for the Landsat satellites. NASA built and launched the satellites, but as soon as they were successfully on orbit, the operations of those satellites transitioned to the Geological Survey. Now, the first Landsat satellite was launched in 1972. This graph begins with 2008. So 1972 is probably over here on the wall. For 30 plus years, the United States sold Landsat data for $500 a scene when the federal government operated the satellites, $4,000 or $5,000 a scene in the mid-'80s when the private sector operated Landsats 4 and 5. And at the peak of data sales, absolute peak of data sales, 53 scenes of Landsat data were sold. That happened to be in 2001. 53 scenes a day. Now, calculate 53 scenes a day, 365 days a year, $400 or $500 a scene. It's a substantial amount of money. It was $4.5 or $5 million that was coming from data sales to one government agency. It was not a good investment for the United States. We looked at who was buying those 53 scenes a day. Number one, other government agencies, mostly the Department of Agriculture. Number two, universities. Where were the universities getting their money? From the National Science Foundation. And number three, contractors getting their money from the Defense Department. So for this middle resolution data in the United States, we were just taking that $4.5 million from one federal agency, incurring administrative costs at each juncture, and putting it into the pocket of another federal agency. Now, it happened to be my agency, and so we were benefiting from $4.5 million a year, but it was not a good investment for the federal government. So we went to the White House, we went to Congress and said, listen, just give the data away. We believe it will be better for the economy to just give the data away. And this graph shows the results of distributing the data openly and broadly over the internet. It jumped up 2 orders of magnitude, 53 scenes a day to 5,700 scenes a day. To this day, 5,700 scenes a day are downloaded globally. So the number now is over 25 million Landsat scenes have been downloaded globally. What's that mean? Some analysis that was done in 2011 showed that to the United States alone, the benefit of that policy was $1.7 billion. There was also a positive effect to other economies around the world from this policy change in the United States to the tune of $400 million for a sum total in 2011 of $2.1 billion. That $2.1 billion far exceeds the $4.5 million that one federal agency was getting from data sales. So governments, one, have invested, the taxpayers have already paid for the satellites. They have paid for the people that are operating those satellites, or those stream gauges, or those weather stations, or those soil moisture stations. And so what we are advocating is if the citizens, the taxpayers of your individual countries have paid for these observations, they are entitled to the information at no additional cost. We saw the same thing in Canada with their RadarSat data. This shows from 1996 out to about 2013, when they opened it up to at least other federal agencies. The average sales or download statistics for RadarSat data was on the order of 5,000 scenes a year. As soon as they at least allowed other federal agencies to get access to the data, it went up by 1 order of magnitude. 5,000 scenes a year up to now almost 40,000 scenes a year. We would argue that if Canada opened up this data to the world, it would see the same kind of increase, 2 orders of magnitude, that Landsat saw. The Copernicus policy here within Europe for broad open data, I think, is largely based on data like this. It is good for the economy for government institutions to share their data. So let's transition just real quickly into agriculture, because you, better than me, know the challenges that we've got globally in this particular area. So I'd like to put a quote up from co-founder of Helical Outposts. Uncertainty is the enemy of investment. Shared information is the antidote to that uncertainty. So let's look at, this happens to be monthly wheat prices from 1960 to 2011, 2012. Look at the relatively stable era in the 60s and 70s, and then 60s largely. As soon as we get into the 70s, the early 70s, you start seeing price hikes in, this is monthly wheat prices, but global wheat prices, okay? And then as soon as you come out into the 2009s, 2010s, you start seeing swings on the order of three times that errors that we had back in the 60s and 70s. So what we're advocating is that if you do want to create a more food secure world, somehow we've got to go back to a more stable pricing scenario like we had in the 60s and 70s. So what are we, the Group on Earth Observations, doing about that? Bringing countries and participating organizations together. So this happens to be a graph that shows a vegetation index on one day of the year. This is August 13th, 2012, and all this shows is the vegetation on this one day compared to the 10 years before this one day. So you can see indication that the vegetation is not particularly healthy in the central part of the United States, here through Europe into the Russian Federation and some parts of Asia. And yet, if you look at southern Canada or also parts of Asia, you will see that in those areas there was healthier vegetation. Now, this is a one-day snapshot. So what we would argue is if Earth observations can help create this kind of information, why are we not feeding it into the process much earlier so that it could ultimately create a more food secure world? So about this time, it was 2011, the G20 agricultural ministers came together and said, we would like you, GEO, working with AMIS, the Agricultural Marketing Information System. It's a program or an entity located at a FAO in Rome. It's not part of FAO, but they are largely responsible for the pricing associated with these major food crops. So since September of 2013, we are now providing monthly global crop conditions to the market monitor, and these are the participating organizations in that. Now let's fast forward. That last graph was 2012, and it showed the drought situations. This happens to be August 2014, 2 years later. Again, crop conditions operational since September 2013. We now have 36 institutions, 22 countries, 7 international organizations, still largely the 4 major food crops: maize or corn, wheat, soybean, and rice. And what you can see here are healthier conditions in central United States, a watch or kind of an alert condition for southern Canada, good conditions, certainly favorable conditions here through Europe, and then again as we get into Asia, areas that are more of a watch. So these are global snapshots of the institutions that are coming together, and yet you can start to drill down to any one major food crop, in this case rice, and in any one country, in this case Thailand, for rice. So we would argue it's not going to be until we can get governments, countries of the world, institutions of the world coming together, working on this, that we're going to have any kind of global impact on that pricing condition. So, just real quickly, and again, many of you in the audience know this, and that is, as we look at space-based imagery or Earth observations from space, clearly spatial resolution and temporal resolution are important characters. This just happens to be, let's look at the continuity of hedges, and you can see with increased resolution of spatial data, your analysis of the continuity is really important. And so a number of different sources, and in fact, in this case, many commercial providers are shown with this Earth observation imagery. The last couple slides are, again, to show the impact that public policy has on these conditions. This is an area in the central United States, largely a corn and soybean growing area in Iowa. Not quite Michigan, George, where you went to school. But look at the rectangle, the blue rectangle in each of these squares. So each square, 2000 down to 2012, a snapshot, and just look at the two colors, corn for yellow and soybeans in green. So for that rectangular area, you see in 2000, mostly soybeans. And in 2001, you see corn. In 2002, you see soybeans. Back to corn in 2003, soybeans in 2004. Now look at 2005, 6, 7, 8, 9, 10, 11, back out to 12. Corn, 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 corn. The United States had some ethanol legislation, regulations that went into effect in 2005. So farmers were paid subsidies to plant corn rather than soybeans. This is observable from space. It wasn't until 2012, when those ethanol subsidies were removed, that soybeans came back into the rotation. So again, when we talk about biodiversity and ecosystems, then rotating crops from corn to soybeans is good for the soil. The nutrients that are pulled out one year are replaced naturally by a different crop the next year. And so you can see that it was not good to go to a mono agriculture. And again, I think information like this is so important to get into policymakers' hands so that you can see the impacts of your legislation. And then the last graph, and I want to apologize because this is a little complicated, but we were talking about it at dinner last night, on how we could bring some of the lessons from the numerical modeling, numerical weather community to agriculture. And how come we're not doing that? So what you're looking at here is a graph courtesy of the European Center for Medium Range Weather Forecasting, and it goes from 1981 out to 2014, and it shows the improvement in 3, 5, 7, and 10-day forecasts. So the 3-day forecast in blue, 5 days in red, 7 days in green, and then 10-day forecast in yellow. So over that 30-year period, 40-year period, you see improvements over each of those graphs. In fact, pick a line out in 2013, trace it back, and it will be as good today in 2013 for the 10-day forecast as the 5-day forecast was back in 1981. But look at the top line and the bottom line of any color. The top line are the estimates in the northern hemisphere. The bottom line are the estimates in the southern hemisphere. And if you look at the 2001, 2002, 2003 time frame, the southern hemisphere and the northern hemisphere correlations came together immensely. This is largely due to the introduction of space-based observations into the numerical weather forecasts. Now listen, in situ ground-based observations are essential. Let me make that very clear, because we are only looking at radiances or reflectances from space. We are not looking at actual values, so you need in situ measurements. But in this case, for numerical weather prediction, in the southern hemisphere, there weren't a lot of land masses to take those in situ observations from. So a tremendous increase and improvement occurred largely between the northern hemisphere and the southern hemisphere as soon as space-based observations came to the table. So I guess what I would argue is if the numerical weather community can do this global modeling between space-based, ground-based, northern hemisphere and southern hemisphere, why are we not bringing these same kinds of advances to agricultural industries and markets globally? You have the data that could influence this story. You have the data that could in fact create a more food secure world, and we need to do that. So I guess I would just say countries have borders, Earth observations don't. I have to say that I stole this or adapted this from an advertisement a couple weeks ago in the New York Times. The actual quote was, "Countries have borders, stories don't." They were trying to sell their online magazine. But what I would say is countries have borders, Earth observations don't. We need to do a better job of sharing these Earth observations globally. If this young farmer has any chance of creating a more food secure world, then we've got to bring this information to bear. And just in closing, our Mexico City ministerial, where our 100 ministers from our 100 governments will meet the week after next in Mexico City. We very much hope that a Greek minister will be able to join us at this meeting. We hope those of you that belong to the group on Earth observations will also join us. That's my last slide. So thank you very much, George.